Hi everyone, and welcome back to our fourth part of our series, Music and Patterns in TidalCycles. So in the last episode, I said we were going to talk about continuous patterns and randomness this time. Actually, I decided that instead I'd rather talk more about what samples are. I'd rather talk about how they work, what they are, how they're made, and the kinds of manipulations you can do on samples and how they differ from the synthesizers we've talked about so far. So the very first thing I want to do is explain what the difference between synths and samples even are, because I've been using these terms kind of a little loosely. I haven't really defined them, and it's about time we fix that. So by synths, I mean things like the super piano, super noise, super chip. These are software, or in the case of like an actual like physical synthesizer, hardware, electronics, that generates the sound when you send the signal that says this note should be played. So I'm talking about like how when you pluck a guitar string, you hit the key of a keyboard, like a piano keyboard, the sound is made right then and there. Samples are just audio files on a computer. They're usually wave files, .wav, which are a high quality uncompressed audio. It's not the kind of thing you'd keep a music collection in unless you wanted to borrow server farms from Google, but it's very good for storing small bits of sound that you want to be really, really high quality for making music, your samples. So since these are pre-recorded sounds, there's actually an awful lot of extra tricks we can do on them that we can't do with synthesizers. And we're going to explore some of those. The first of which, and one of the more fun ones, is you can change the speed at which a sample is played. Now, when the speed of a sample is changed, it also changes the pitch of the sample. You slow it down, it sounds deeper. You speed it up, it sounds higher. And in fact, doubling or halving the speed is the equivalent of raising an octave or lowering an octave. And so our first example, we're going to go back to the hi-hat pattern we've used repeatedly. And let's just hear that as a reminder. And what we're going to do is use the modifier speed. And let's cut it in half. So as you could hear there, that it sounds a little deeper. It's an octave deeper technically, and it's a little more, I think, mechanical, artificial sounding, a little moody. And that's a sound we're going to go for in the examples this time, where we're going to go for something that's a little slow and a little noisy and a little, maybe even a little somber sounding. Now, like most things with modifiers, you can pattern what goes into speed. So I'm going to change this pattern a little bit. And now, so as we would expect, the first half of that cycle, the speed is going to be a third of normal. And then the second half of the cycle, it's going to be 0.6 of the normal speed. So I think this sounds a little, again, a little artificial, a little mechanical, a little industrial. And speaking of industrial, that's actually the next sample I want to talk about. It's one of my favorites in the default samples of Tidal. And so let's just hear it. And let's hear it normal for just a second here. So kind of a metally crash sound, sounds like machinery. But let's go ahead and change the speed. And so reading this again as a reminder, the angle brackets means that it's going to change between those values each cycle. So it's going to be a quarter of the speed, 0.4 times the speed, and half the speed. Okay, so let's listen to it now. And you can hear that it sounds really different when you drop it enough, and since you're playing it at a lower speed, it also takes longer. So to let you in on a little secret, samples in Tidal are generally not just samples, they're whole families of samples. And how do you select the different samples within a family? Well, with our old friend, the modifier N, which we've been using to select notes for when we use synthesizers like super piano. N of 0 for synthesizer means have the synthesizer play middle C. Well, N of 0 in sample terms means choose the first sample. And then N of 1 is the next sample, 2 is the sample after that. So let's just create a little pattern here, and just going to type this quick. So now let's hear what the different samples sound like when they're combined in this pattern. So yeah, there's a few different sounds, and we can make a variety of percussive noises with this. And in fact, I'm going to add a few more things to this, including, let's add a little resonance. Let's have it, let's do the thing where we have, sometimes we stutter it, and we want the second note to be played at 70% of the volume, and let's have that be played an eighth of a cycle afterwards. Okay, so let's hear how this sounds. And the last trick I think I want to do here is go ahead and pan this sort of around our ears with the sine wave like we did in the last video. And now if we actually combine that with the hi-hat, and I'm going to add another effect on the hi-hat actually. actually. It's one we haven't seen before, but it's an echo effect called delay. So I'm going to do delay, and you, like a lot of the modifiers, you give it something between 0 and 1. 0 means it's completely off, 1 is sort of as much of the effect as you can apply. So I think we've got our percussive bits there, but let's come up with something a little melodic. But we're still going to do it with samples. We're not going to use like super piano or something like that this time. What's kind of neat is some families of samples actually have multiple samples corresponding to different notes. We're going to use in this case one called RASH. And so the thing about RASH is that it actually contains 72 samples in that family. Why? 72 is 6 times 12, so it's 12 octaves worth, 6 octaves worth of 12 semitones each. And because of that, we can treat it almost like the keys on a piano. Now, if you remember what I said, 0 normally means middle C, which is the 4th C. Now, in this case, 0 is the first sample, which is the lowest note. So we're actually going to shift it up a bit. We're going to shift it up by 4 octaves. So we're going to 4 octaves, that's 4 times 12, that's 48 semitones up. So if we try to play it, we should hear something kind of nice. Okay, so that's the sample we're going to use for the melody. And in fact, instead, we can use the same tricks we've used before about using scale. So here, I'm going to say that we have 8 of these per cycle. And for our actual notes, let's say we want something like plus 48, and then scale Dorian. Dorian being a minor scale, it was used in very like old traditional music, like Greensleeves is in Dorian mode. But then also actually a lot of like modern American music, jazz, blues, a lot of rock was done in Dorian mode. So a lot of 20th century music. So just have a simple pattern, and let's hear it, how it sounds. Now, one thing that's cool, we're starting to get into the things that you can't do with the synth. And one of them is, so we talked about playing with the speed, right? Well, what happens if you make the speed a negative number? Now, if the first thing that occurred to you was it plays backwards, that's absolutely right. We can start having our music play backwards. So, and we don't want that all the time. Let's make that a sometimes thing. And how do we want to do this? We want to multiply the speed of the sample by -1. And by doing that, we're going to make it play backwards about half the time. So let's listen to this. Okay, so you can hear that about half the notes are getting reversed per cycle, and this is kind of fun. But one of the things I want to do from here is have our melody get made from a continuous pattern, like a sine wave. Now, this is one of those rare moments that I'm going to show you something that won't work, and it's to help start the conversation about what we need to do to make it work. I try to reserve this trick of teaching as rarely as possible, but it is time to do it. So we want let's do scale Dorian, and let's have it be applied to a sine wave. Now, first thing is that a sine wave, it varies between 0 and 1 in this case. Now, if you've taken math classes where you're like, wait, it doesn't normally go between -1 and 1, yes, that's normally true. Things like sine waves and saw waves and continuous patterns in general are all scaled between 0 and 1 because that's what the modifiers generally expect. So that's the reason why we can put sine drop it right into pan or speed or anything else. Now, we want it to take on the size more like notes, and there is a transformation called range, which will let us do something like, let me see, we can go between -4 and say 8, and that should scale the sine wave, so at the bottom of the wave it's at -4, at the top of the wave it's 8, and then it sort of varies up and down the way the sine wave curve would normally, kind of circling around. Now, I'm going to do this, and oh my goodness. Now, if you're on mobile, it might not be super easy to read the red text that appears at the bottom. Also, if you've been playing around, you may have already had something like this happen to you. But I'm just going to copy paste the text here into the main part of the screen where the text is a little bigger. And no instance for fractional int. Okay, so the point here is that it's an error message. It's not a great error message, and I want to explain to you what it actually means. The problem is scale wants a pattern of whole numbers, like 0, 1, -5, the numbers that don't have anything to the right of a decimal point. Why? Well, because even though there's this whole world of things called microtonal music and really cool stuff of things that are kind of between the normal notes, the scale function is not meant to do that. Scale is a transformation on patterns that takes a pattern of whole numbers and then transforms it so that it's the right, sort of rescales it, no pun intended, so that it matches the scale you give it. Like in this case, Dorian, it matches so that the 0 note is still, middle C, but then shifts things around so that the next note is not C sharp, it's the next note in Dorian, or pentatonic or minor pentatonic or any of these. Now, what that means is, well, sine, even combined with range, is going to give you fractional numbers. It's giving you numbers that have something to the right of the decimal point. That's just sort of normal. That's what a sine wave does. And you're rescaling the sine wave, but you're not making it only take on those whole number values. Now, if you're sitting here and wondering, why doesn't the computer just do that for you? The good reason why it doesn't is because you might want to transform from the fractional numbers to whole numbers in a bunch of different ways. Maybe you want to round to the nearest whole number. Maybe you just want to throw away the decimal point. maybe you want to look at the third place of the decimal, and if it's even, make it -2, and if it's odd, make it exactly 68. There's no way the computer can know exactly what you want to do, and maybe you have a good reason for doing something kind of weird. And this is just a general thing in programming. You kind of have to be explicit about these things, that because computers can't make guesses, they shouldn't make guesses. We should tell them unambiguously what to do. Okay, so what we need then is a transformation that takes a pattern of numbers that have decimal points and then turns it into a pattern of whole numbers. Now, that's not super bad. It turns out that there's already a thing built in to Haskell, the language underlying Tidal, called floor. Floor just throws away the decimal point. Essentially rounding down, always rounding down. And if we do something like floor of 1.2 and we hit Control Enter the same way we would if we were trying to start some music, what you get at the bottom of the screen is the result of that code running. In this case, we get a thing that says, we get this little T that just means, the most recent output, and then 1. Floor of 1.2 is 1. Okay, now, are we done? Well, no, because now, are we done? Well, no, because floor is a thing that takes a fractional number to a whole number. We want something that takes a pattern of fractional numbers and turns it into a pattern of whole numbers. Basically, we want to take something that operates on numbers and turn it into a thing that acts on patterns of numbers. And thankfully, there's already a way to do that kind of thing in Haskell. And so we say fmap floor. I'm going to put in a little more spacing. In fact, actually, I'm just going to do this. There, fits nicely on one line. Now, fmap, what that stands for has to do with some mathematical ideas about how programming languages work, and while it's a really fun subject, it's kind of an aside here. So instead, what I'll say is fmap takes the thing that operates on numbers, or whatever you want. Let's say you were trying to take a pattern of strings, so like names, and then turn it into a pattern of numbers, or you were trying to, any sort of like transformation on data. What you can do is you give fmap that thing you want to do to the data, and then it turns it into a thing that acts on the patterns, the whole collection. That's kind of what fmap is doing. It's taking the knowledge of how to do something and then applying it repeatedly as is needed to sort of the bigger picture. So now, with all that being said, we can use our continuous pattern with range to actually create whole numbers and pass that to the scale function. Okay, so that's clearly going up and down with the sine wave, and this is the start of us learning how to make things like melodies with continuous patterns, which is going to be super useful once we start talking about randomness for real. because everything random is a kind of continuous pattern. Now, this has all been with the understanding that you have a bunch of samples that can change, have different pitches from each other, and you can use those. Now, that's not always true. Sometimes you just have like one sample for the melody or a small number of them. And then what you need to do is manually change their speed to change the pitch up and down. And that mostly works. I'll explain why it has some caveats, but there's you don't have to manually use the speed modifier and figure out exactly what to multiply or divide by to get an exact note. There's actually another modifier called up. And up lets you kind of just pretend you're dealing with notes and changes the speed accordingly. So the equivalent of what we've done here done with up instead So what we're going to do is we're just going to say n of 48 and then up of the scale. So this means that we're going to be kind of just taking the 48th, the middle C sample, and we're going to speed it up and slow it down. And let's kind of hear how these compare to each other. So we're shifting back and forth from the one with up to the one that's using multiple samples. Could you hear what the difference was? Because it can be a little subtle. It stops being subtle once you start going really high or really low. But if you're staying within an octave or so, it can be a little hard to hear. But the difference is all the samples in RASH kind of have a set length to them. But if you're speeding up or slowing down the samples, you're actually changing the length. So the higher it goes, the more kind of clipped and weird it's going to sound. But they're pretty close if you stay within a small range. So that's the trick you're going to use if you have a smaller number of samples. You're going to use up to shift it to shift the sample's pitch up and down, pretending like you're dealing with notes on a synthesizer instead. Now, the last thing before we're done that I want to talk about, something called granular synthesis. And granular synthesis is this kind of fun thing where you mess with samples by chopping them into little pieces and then playing with them. Now, so we're going to introduce another sample, kind of a slightly silly one, but it'll turn out to be sort of fun. Okay, so that's like some DJ yelling at the show, right? Now, there's two kinds of granular synthesis. Actually, I'll leave that slow too there. There's chop and striate. We'll look at chop first. So what chop is doing is that it takes the individual, it takes the samples played in the pattern and it chops them into little pieces. So in this case, we have one rave, and then that gets chopped into 64 small bits of equal size to each other. Now, the nice part is we can start doing some kind of weird stuff here. I'm going to copy and paste an example I wrote earlier. And since we're now dealing with multiple things being chopped into small pieces, we can start having some fun with the way continuous patterns work. So in this case, we're going to have the range is going to be varying across the chopped pieces. So not all of them are going to be at the same rate as each other, so they'll be at different pitches. And we're going to degrade, which is it's the equivalent of doing the question mark inside a pattern, where degrade is going to throw away, on average, half of the sounds in the cycle. So if we do this, yeah, that's kind of cursed, but I think in a fun way. Now, the other thing we can do, and this is actually the one I happen to really, really like, is striate. Now, the difference between striate and chop is hard to explain a little bit. So, there's only one sample, they're basically the same thing. If you have multiple samples in a cycle in your pattern, then what it does is, so here's an example. If I have I have a sample that's just someone saying, "Hi, how are you?" And then we have that 4 times in the pattern, right? So, hi times 4. And if we chop that 4, then that means that's going to chop each of those into 4 pieces, but then play them in order. So it'll be hi, how are you? Hi, how are you? Hi, how are you? Hi, how are you? Striate reorders things. In fact, so striate 4 of hi times 4, to keep our example, is not going to be like keeping things in order. It's going to take the first slice of each one and then stick them all together. The second slice of each one, stick them all together, and do it like that. So it would actually come out as hi, how are you. So this is going to be pretty useful and pretty fun. So I have another prepared example here of using striate instead, and going to take out the scramble for now, because we'll talk about scramble in a second. But for the Strate 64, I have 4 raves here, and I also dropped their pitch. So let's hear it. So the fact that there's like this weird stuttery echo is because of how it's taking multiple copies of that. It's taking multiple copies of the sample, and they kind of like interleaving them into one really weird stuttered one. And the fun thing is we can start doing things like, here is a variation of degrade where you actually specify the percentage. So in this case, 20% of the events are going to get thrown away. So let's hear that. That sounds kind of weird and crunchy and like demented robot-y. And then what we can do also is, so there's other things like scramble that are transformations that take all the individual sounds that are going to play in a pattern in one cycle and then reorder them randomly. And since we have chopped our rave into a bunch of little pieces, now we can just scramble it randomly and just completely break it so it doesn't even sound like human speech anymore. Okay, so that's the start of granular synthesis. But in this case, for the sounds we want to do here, we want to do something more with industrial. And copying and pasting this over, we have this sound. So from here, let's see, I think there's probably some other things. Yeah, here, I'm going to put a distort on our little melody bit. So now let's combine all of this together. In a more interesting pattern shape. Okay, so that's the end of our example, and also this is the end of the current video. Next time, we will be definitely delving into randomized patterns and playing around with making some music that is as random as possible while still having some order, having some structure, sounding good. So until then, I hope you keep experimenting with Tidal and enjoying music.